we are very glad to be in this nice hall, in the hall of Lithuanian Agricultural Advisory Service. I wish you a very successful discussion, networking. And before we get started, I would like also to express our sincere appreciation for our sponsors. You may see that we have several sponsors. We couldn't do this event without the help. And thank you very much again for your attention. I hope it will be quite interesting because soil is very important, as you know, for everyone. And soil physics might be some special thing, but also it's very important as soil chemistry, soil biology. So we have, I think, very interesting and important symposium today. And I would ask to tell some welcome words. Our, how to say, honorable members of our committees. And I would like to ask Professor Vidmantas Stanys from Lithuanian Academy of Sciences.
Good morning, ladies and gentlemen. It's very big pleasure for me to welcome you to this international symposium. As you know, our decisions are largely determined by the times that dedicate priorities and the time we have to deal with it. The world's population is growing, but the land on which useful crops are grown is shrinking. The soil is a key resource for sustainable food, but according to the statistics, 42% of the soil degraded. Of the more than 7 billion people in the world, 3 billion become insufficient food. 2 billion consumes inadequate food. On the other hand, climate changes and geopolitical situation in the world are changing the order of the world's major problems. It should be mentioned that never before have scientists had such advanced equipment. It has never been so easy to collect endless data. However, before collecting new terabytes of data, new data, it's necessary to make sure that the correct question have actually been asked. On behalf of myself and Academy of Science, Lithuanian Academy of Science, I wish the conference successful work. I think that during discussions, you will find right questions and you will find right solutions. Good luck, success for you.
For the next welcome address, I would like to invite Director of Lithuanian Agricultural Advisory Service, Dr. Edvardas Makelis.
Dear guests, participants, ladies and gentlemen, I'm very proud to pass for you great wishes for this conference, and we are one of the organizers of this conference. And land is main mean of production for agriculture. It was, it is, and it will be. Therefore, this Congress, 5th Congress of Symposium of Soil is very important for carrying things, what is going on in our politics and our agricultural practices. And I think it will be good impact for farmers' practices in agriculture. therefore, I would like again to greet you to be participants and organizers of this conference, and wish for you great success for this event.
Also, I would like to tell some welcome words. Deputy Director for Research from Lithuanian Research Center for Agriculture and Forestry, Dr. Vita Tilvikienė.
Dear organizers, dear participants, I'm pleased to welcome you today on behalf of Director of Lithuanian Research Center for Agriculture and Forestry, Dr. Gintaras Brazauskas, who unfortunately couldn't participate in this event. Soil is the key importance for all of us, and that is background for our lives. That is the source of our food. That is the background for our social life, for our surrounding. And as it was told yesterday, you're going to talk about very thin layer of the soil, but the layer which is of key importance for us. So I wish you very good conference, productive conference, good presentations, fruitful discussions, and I will be also very interested to hear of them. Have a good event.
Thank you very much. I hope we will be successful, in fact. And now I will give the table for our moderators, Professor Andrzej Bieganowski from Poland and Dr. Livia Zariņa from Latvia. So you will invite presenters and you will be the heads of this first session.
Good morning, everybody. Thanks to organizers of the event, today we have great opportunity to learn about the latest research on the physical properties of the soil. And this morning session will be led by us, as already introduced, Professor Andrzej Bieganowski from Institute of Agrophysics, Polish Academy of Science, and me, Livia Zariņa from Latvia, from Institute of the Agricultural Resources and Economics. This morning session we have 5 presentations, and as we will listen so 5 reports, and as the first we introducing you with first speaker, it's Dr. Virginijus Peiza, and he will tell about fertility and sustainability of morainic soils. Doctor is from the Lithuanian Research Center of Agriculture and Forestry. He is chief of department, and his research areas are soil sustainability and quality, physical and hydrophysical properties of soil, and also agroecosystems and sustainable agriculture. In this today report, he will turn attention to moraine soils, and we normal people know that moraines coming after glaciers, and we simply know that glaciers are very old, and how those properties of moraines influencing agriculture, Professor will tell us.
Thank you very much.
Before, I would like to add something. In our meeting, participated nearly 40% in the internet. So I welcome everybody who is not in this place, and I invite you to active cooperation. If you will ask questions and it will be not possible to ask because of the timetable, we will pass all questions to the speakers. Thank you.
Okay, thank you very much. Dear ladies and gentlemen, I am also very glad for being here at the 5th Soil Physical Conference. When the organizers of this event asked me to make presentation, they asked that the presentation would be not concentrated on only one field trial, but as wider scientific results will be provided to you, and also include the features of our soil according to the future from our nature, what we inherited, and what we are planning to manage our soils in the nearest and far future. Due to this, I decided to use the results of the national research program, which is called Agroakademija. And the results of this research, I think, are very important, and they involve the soil features from different soil types and pedological climatic conditions of Lithuania. And in this program, a national program, as you see here, the list of scientists, researchers who took part and provided data. So I am really glad, and I thank all of them. And I use this data here and show to you. And I think that now I can start with my presentation. The first slide I want to start is the main problems of present day, which we see problematic at the moment in Lithuania. The first of all, we see the soak reduction in both mineral and organic soils. The second problem is soil compaction. The third is crop nutrition. The fourth is soil water conservation and drainage problems. Acidification of soil, it was a big problem and is still remaining up to now. And I think it's even more increasing in the nearest future. And the last one, but I think it's not the least in all this, which is not provided by me here, but it is a reduction of greenhouse gas emissions. So at the moment, these are the main topic problems which we see here in Lithuania. I think that to know what soils we have, what we should do in the future is the main thing to look back, to know the geological history of our soils, to know the fertility, productivity, what inherited we from Mother Nature and what we can expect in the future if we are talking about our soils, best or good management. So this is the historical picture from 1914, and it's taken in the eastern part of our country. So it's very typical picture. You see here a lot of stones with sharp depressions in the landscape. And what is more, that our soils at that time, they were really poor in plant nutrients. We were acid by nature, so we inherited really poor quality of the soils. Much better situation we have in the middle part of the country, where we have not acid soils, and we have a plain relief and the ability to yield for crop sown in the middle part of Lithuania is much better than in the eastern and western part of our country. And here is two pictures. On the top right side, you see the Lithuanian map, and this hilly landscape shown in yellow color. So as you see, we have about majority of our territory, which is hilly rolling. We have some hilly soils, and in total we have 68% of our hilly soils in Lithuania. And the next slide, next picture, presents the real situation at this time of our hilly landscape. And I am really proud that you see it's really good looking. It's not on the wide, big fields. We have an arable land, we have a grassland, and some trees, some small forests inside this country area. Anyway, to take care about our hilly soils, we prepared different hilly soil management recommendations, and one of them it concerns, we think, the main thing. It is crop rotation recommendations in hilly landscape. Our hilly landscape is divided in several types according to the steepness of the slopes. We have so-called lowland, then the slopes are from 0 to 2 degrees in steepness. And these soils are suitable for all crops to be grown. So actually these crop rotations used for level landscape, similar to some small hilly landscape on the hills. We have only recommendation for gentle sloped land is from 3 to 5% of the steepness. All crops may be grown while hoeing, I mean potatoes, crops should be avoided. Another type is hilly soil, and slopes from 6 to 10 degrees are included, and perennial grasses, winter cereals have to be grown on these slopes. And the hoeing crops growing is absolutely prohibited. And we have steep slopes. It's more than 11 degrees. And these slopes are suitable for perennial grasses growing only. Another situation what we have in Lithuania, and as I said, it is soil acidity, and this feature is generated from our glacial period. And you see 4 maps of Lithuania. Then PF was investigated in different years of the last century. And if you look at the first one, from 63 to 57, you see that all the hilly region, Western Lithuania, and another hilly region in the east and south of Lithuania are very acid. You see, it's more than, it's red color, it's more than 50% of all land is acid. Intensive lining took place in 1985 and 1993. This red color reduced very sharply, and this only few regions exhibits red color. From 95 to 2005, you see some more red colors are rising up. So the reason for that is the soil was not so lined, and the latest investigation here, after 2015, you see that we have again some regions becoming again very acid. So this is a really big problem in Lithuania, and we think that we should take much care in the future concerning acidity reduction by liming. It's very important to know, especially at this time, when the prices for mineral fertilizers are growing up actually every day. And the investigation on the soil mineral amount in the soil becomes very important. And as you see here from the investigation from 2020, the one map stands for the springtime investigation of nitrogen in soil, and another is for autumn. And this, as you see, very big differences from springtime nitrogen amount in soil and in the autumn. You see that very high increase in nitrogen is this color. You see is in the middle part of Lithuania, where a very intensive farming takes place. And also much increase in the right and left side from the on this map. It means that we should take care very much on amounts of fertilizers when we apply for the crops which we grow. So the conclusion that the monitoring information should be done. And this helps to save and nature, environment, and also reduce nitrogen fertilizer application. Soil sensitivity to compaction. Here is the map of the Europe, official map of the Europe. And what is interesting, if we look at the Lithuania, we see that Lithuania, we have all types of soils sensitive to natural soil compaction, starting with very high, this high, and also medium. And only very few areas we have this low compaction, this green color, actually brown and dark red prevail in Lithuania. So it seems that we should take care very much when we are going to take care about machinery usage in the agriculture land. So timeliness of the soil tillage operations due to avoid compaction of the soil. I provide also data for maximum soil frozenness during winter season, during 12 years period, during the last 12 years period. It's really very clear that we had some years, then we had maximum frozen depth up to 75 centimeters. But if we look at the last 3 years, here, we see that cold winters are going to be disappear. Actually, no frozenness inside the soil. So then we've been taught in the higher schools some years ago. Our lecturers used to say that winter freezing helps to loosen soils, and that agronomists and farmers should be lucky that we have deep soil frozenness during winter. So in the springtime, we can easily till the soil is loose, and the crop can root very easily and provide good yield. So in our situation, it seems that the nature will not help to us at this moment, because warm winters are prevailing in Lithuania. So climate change we really see as a fact in Lithuania during the 3 last years. Some data concerning soil penetration resistance situation. Here is farm field measurements in different fields. Here is the sign plus in the yellow background and sign minus in the red background. Here is UC line 1.5 megapascals. We think that this is the critical value, penetration resistance, which being higher than this value prohibit the crop rooting ability to go to deeper soil layers. So what is on the left side of this red line? It is no problem for crop to grow. And you see we have even very different depths of the soil, starting from 9 centimeters, then it reaches 1.5. But we have also some fields with more than 48 centimeters and no problem. So it means that it's not so easy to say that soil compaction will take place in all the fields, in all the situations. So each field should be investigated separately. And in that case, I think that in the future, recommendations for practical farming should go not as a general one, but as specific for specific field and individual farmer conditions. Some official data. At present time, reduced tillage and no tillage and direct drilling, is going up, and the interest is also gained up, and the politics and the Green Deal stimulating that these plowless tillage systems will be used as wider as possible, and even financial support is provided for farmers to increase the speed of this new tillage system. Here are official data for 2016. Unfortunately, these data are really old, but officially at the Eurostat, it's only the data for this year. No more fresh data. So as you see, I want to show Lithuania being in the list. So as you see, with Lithuania, we use conventional tillage, and this system is prevailing up to 88% of the total arable land. And about 10% is used for conventional plus zero tillage. Among these two systems, the zero tillage, you see, occupies about 5% maybe maximum. If we look, let's say, to our neighbors in Poland, let's look here. Yeah, you use even more conventional tillage than we do. So this is statistic, but I think the situation now is much changed, because I think that we should be at the moment, Lithuania could have about 25% of conventional tillage systems in total. I think this number should go up and increase year by year. Here is the list of advantages of plowless tillage, because each system, is it traditional or it's a new one, in that case plowless, it has positive and some negative points. So here is positive points. You see here a number of positive points. Economy, it means fuel, time, and acreage coverage, speed. Less driving on soil. No need to settle the soil, as it usually recommended after plowing. You know that after plowing, the volume of soil increases up to 25 or 30%, depends on the soil texture. No wide park of specific machinery for different tillage operation is required. So it also saves money. It's less risk of soil erosion. It means tillage erosion, water, and wind erosion. Fast and even crop germination, and this is especially important in dry spring. We usually had 2 last springs, very windy and very dry. High organic matter content within topsoil layer. Higher earthworm population, because it is more higher organic content. Less risk of soil crust formation because of higher organic matter content. More plant nutrients accumulated. This is some negative point. No stones are lifted up when the soil is plowed. In that case, they are not coming from deep soil area. And wheel ruts of machinery are not so deep during harvesting compared to plowing. But as I said, the plowless tillage system has some disadvantages. So its straw residues on soil surface may inhibit good soil-seed contact to reduce soil quality. Better conditions for pests and diseases to survive on topsoil, because the straw is living space for many of diseases and pests. Plowless tillage rely much on herbicide application, especially on glyphosate. And you know that EU is thinking in the future maybe to abandon this glyphosate application in the EU completely. So how it will be this plowless tillage system in the future that glyphosate is not available, it's a question open. Need for specific and expensive tillage sowing machinery. Yes, plowless tillage use less machinery, but this machinery is much more expensive. Better soil, lower soil drying in the spring. And in our cases, some farmers see this problem. Risk of cultivation pan formation and soil waterlogging conditions, because our soil, as you saw, is very much related to soil compaction, natural soil compaction. Dry topsoil is less nutrients available for plant and nutrition process. This is very important. And nutrient accumulation on topsoil may be risk for their loss during erosion because they can be washed down. And crop yield is year dependent and not so stable compared to conventional tillage. We also have a new problem concerning, as I said, cultivation pen formation. We all of us know about plow pen formation, but in some areas, some farmers already have plow pen. So one soil and two plow pen. Emission of CO2, as you see here, the most intensive CO2 emission is from grassland. These are green line, and it should be. If we look at the different tillage systems, we can say that there are no statistical big differences between different tillage systems concerning CO2 emission, but some trends are seen. Then no tillage system, reduced tillage system provides more CO2 emission. We talk about soil organic carbon concentration on the topsoil. Especially we found that red soil, which is not so fertile soil, which is not so good for crop yielding, it really responds quite well when we use different tillage systems. And in that case, the soil organic carbon concentrates on the topsoil. Positive and negative points of agrarian activity. Here is like summary that if we compare different soil properties and different agroecosystems, this forest on different soils, we see that aggregate stability is the problem number one, and especially on the limnoglacial clay on heavy soil, we have also the problem, the soil water permeability. And here is the data, actual data, and you see this data from the limnoglacial soil. You see it's the permeability of the water falls down very much compared with the other types of the soil. And it is even twice as higher. It means twice as lower compared with other types of soil. There are conclusions from our Agroakademija national project. I think that we should concentrate on this conclusion, that the negative influence of intensive soil management on physical soil life can be described in the following order: good soil, higher than clay soil, higher than candy soil, and higher than acid soil. While for agrochemical soil environment, the order is candy soil, good soil, clay soil, acid soil. And here is the practical recommendation from this big experiment, this big program. You can find it in our LAMS web page, and here is address. And here is, thank you much. Thank you very much.
Thank you, Mr. Feza, for your interesting information, and this is very useful for every practical farmer. Audience, do you have any questions to presenter? Please, one small questions you are welcome to give. While others are thinking about questions, I will give my question that roses while I listened to your presentation. You said that you have advices already, recommendations for farmers. Which of the recommendations are the most main for minimizing of nitrogen in autumn time in fields?
Minimize the nitrogen losses. It should be, its recommendation is common for all regions, that some cover crop should be left growing, should be left green in the autumn, sown in the late spring, in the autumn. And the best way would be if it would be frozen in the early spring during the winter. So this will help to take out the nitrogen from the soil and for crop to grow the biomass and be after that food for the crops which will be sown in the spring.
Thank you. So others, your questions?
If we have time, I have one question more. What about the water availability? It is not for soil, but directly for the plants, but it is the problem for the whole Lithuania, or you have different hotspots?
The problem is that if we look at the microporous, mesoporous, and microporous, the ratio is not good for the mesoporous. So it means that the ability of the soil to save water, it's not so good. So we should think how to increase this mesoporosity of our moraic soil. One way is to provide organic matter. It's very important for us, I think, in our situation. Another thing is to make the soil looser. There are two ways to do that. To grow deep-rooting plants, let's say alfalfa, if it can grow, perennial grasses, clovers, or till soil mechanically up to quite deep soils down to the subsoil layer, and this really popular here.
Thank you very much.
Thank you.
As the next speaker, we inviting doctor from the Institute of Agrophysics, Polish Academy of Science, Dr. Rafael Mazur, and he will give information about erosion topics. And we know that last 150 years we lost nearly half of Earth from this fertile Earth, and this erosion problem is very, very actual everywhere. Please, you are welcome to give your presentation.
Good morning, everyone. My name is Rafael Mazur. I'm from Institute of Agrophysics Polish Academy of Sciences in Lublin. And scope of my research is connected with soil erosion, or to be more precise, with splash erosion. In my work, I use high-speed cameras, surface scanner, and today I will try you a few more information about one of these measurement methods. Title of my presentation is Advanced Method for Investigation Soil Erosion, illustrated by the use of a surface scanner to measure the splash phenomenon. So let's start with a few information about splash. Splash could be first stage of water erosion. This is natural common process connected with water drop impact on soil surface. Water dropped cause detachment and displacement soil particles. It's also connected with deformation on soil surface. Among factors that affect on splash erosion, we can point out vegetation cover, slope of the land, parameters of the precipitation, size and energy of the drop, also soil erodibility. We can see example of a splash phenomenon on left. Drop impact on quite moist soil. It's typical soil sample used in our laboratory. This picture was taken by high-speed cameras. And we can ask why measurement of splash phenomenon is difficult, and it's connected with nature of this phenomenon. Splash is quite a dynamic process and occur on a small scale. Water drop can eject a lot of small, fast soil particles, and deformation can be really small. So we need to use quite advanced, accurate measurement method. And like you can see, we use different method of measurement for different aspects of soil, of splash aspects. First of all, we can use splash tray or splash cups to analyze the mass of detached material. We can also use high-speed cameras to analyze parameters of ejected particles, including number, velocity, ejection angle, trajectory for these particles. Also, we can use pressure sensor to analyze mechanical impulse occur after the drop impact in our sample. And finally, we have microtomography, photogrammetry, 3D scanning for analyzing deformation after water drop impact. And this method will be connected with my presentation. This work presents the possibility of using surface scanner in erosion study, illustrated by splash analysis. I will present result from measurement including the soil with different moisture content and after impact of drop with different with two variants of final kinetic energy. Oh, sorry. So in we use Universe 10 megapixel 3D scanner from Smartech. It's a Polish company. This scanner is based on light structure technology and use white light to measurement. On the left, you can see basic parameter of our units, and this scanner have limited measurement volume. However, it isn't a problem because we have opportunity to match several scans to each other when we measure bigger object. Sampling is about over the 600 points per square millimeters. Accuracy of this scanner is 30 micrometers, and time of one scan is about 20 seconds, but it depends on our sample of settings the measurement. These units have a lot of classes. For example, easy and quiet measurements, high accuracy of measurement, high level of automatization of the analysis of results. However, our scanner have also some weak points. For example, scanner have problem with measure some type of surface, black, transparent, including moist surface, and illuminated object. In the center of this slide, we can see schematic diagram of measurement system. And this system includes drop dosing sets, and we can see part of our laboratory on the right with a lift which allow us to change the height of the water drop falling. We use in this measurement water drop with diameter of 4.2 millimeter, and our drops was falling from a height of 1.5 meter and 7 meter. In this measurement, we use soil sample from Haplik Luvi salt. Our sample after water drop impact was put on rotated table. Then we was carried out the scan. And on the left, we can see a sample of scanner before the scan. Now, what we have after the scanning? The result of the scan is a set of point cloud reflecting the sample geometry. Software tool allow us to remove some errors, some threshold, match cloud to each other, because our one measurement include 6 scan, because we have to measure sample from different sites. Then we finally can to convert point cloud to triangular mesh model, and main part of analysis was made in GeoMagic software. On the right, we can see example of 3D comparison of a sample after water drop impact with reference surface. The reference surface corresponds to the level of the sample before water drop impact, and in this picture we can easily see the highest point of the deformation, a rim around the crater, the deepest point of the deformation, also even some ejected aggregate. On the left, we can see a profile of crater. Profile of crater, which allow us to analyze equivalent diameter and circularity of the crater. So in this graph, in this slide, we can see several graphs with data connected with shape of the crater. We analyze depth, diameter, circularity, also volume of the crater. All analyze quantities increase with increase of moisture of our sample and with energy of the water drop. The depth of the crater was about, the highest depth of the crater was over the 1 millimeters. The higher value of diameter was over the 10 millimeters, and parameters which changed the most was crater volume. Summing up, the data collected with the use of scanner may increase the knowledge about the splash phenomenon. Additional, the measurement method was fast and precise. The moisture content of the sample was the factor which high influence of determined quantities. The increase of energy of the impacting drop also was important. However, the effect was quite small, resulting in statistical significant differences in only some cases. That's all. Thank you for your attention.
Thank you for your presentation. It was very interesting for people who are managing those methods, but for other people who working on the field, for more, maybe some practical question. Do you have from audience somebody? You're welcome to ask. We are here international contingent, and you can ask also in your national language if you would like.
If you have any question, you can contact with me using the
Yes.
mail. This is a problem.
Yes, if you would be so kind on the open conclusion slide, I would like to ask.
Which one?
Last one, conclusion.
Conclusion. Okay.
Yes, you concluding that the effect was quite small, but can you see any possibilities to get result better? Maybe some another kind of methods.
Yes, of course. Because effect was small because we have water drop with one diameter. When we change size of the drop, effect of course can change. This is only for some specific moisture and only for some specific energy of the drop. And we can have bigger differences connected with water drop energy when we change it more.
My colleague.
I invite the participants who are in the internet for the ask the question. There is no.
Oh yeah, thank you once more for the presentation. And as the next speaker, we inviting Professor Kęstutis Romaneckas, and he coming from Vytautas Magnus University, and will tell very important things about his topic impact of tillage intensity on the main soil physical properties. And you know, there is a lot of properties, and main properties we will now introduced by him. Please, your stage.
Dear colleagues, good morning. Thank you for inviting me to this prestigious conference. I'm really proud to take part in this auditorium. Today I would like to speak about the soil physical property. That is main task of our meeting, yes. And you see many different plowing equipment, from very simple older one to the like was cosmetic equipment here and here, for example. And you may see very nicely plowed soil. That's from some contests. Doesn't matter, but really good view. Here, here. Sometimes not very nice view. That is in practice. I don't know about your countries, but sometimes we have such view. This one. This one. That is the best view, as I see. The problem is still the same. Doesn't matter if you have a nicely plowed soil or a little bit not nice, but we have problems. For example, soil harpons. We call these harpons, we call the woman's profile. For women, that's okay. For soil, not. Soil compaction here is nearly the brick for making, for building, for constructing of our buildings. Nearly the same. How to penetrate of roots? More problem. That is quite an even distribution of precipitation during the vegetation seasons. For example, in Lithuania, you may see from 200.5 up to 500. 2, sometimes 3 times differences. And you may see what happened with the infiltration coefficient. If you have the big amount of precipitation, the infiltration is quite weak, low. And you see, consequential here, some lakes, yes, and that lakes not, how to say, permanent, sometimes 2-3 years, really. I say, on the borders, in oilseed rape, in sugar beet. You may see that is not rice in Indonesia, that is sugar beet in Lithuania. Yes? 72 hours and only 28 millimeters. Only. And you may see what is very hydrology. Terrible. Terrible. But we have equipment. That is not very reclamo, sorry, but we have many different equipment. You may see here. And how to solve. In this cover, you may see what's happened, sorry, some in Lithuanian language, but if you have subsoiling here, you may see what to solve this problem. Just break the bricks and you may see lucky sugar beet. Yes, really nice view. Oh, sorry. If you have different types of soil tillage from deep annual plowing up to zero tillage, you see what's happened in the beginning of vegetation. Big difference, yes? But during vegetation, during, for example, less than half year, you see what nearly the same. Like us, you need to summarize that. If you till, okay, during 3-4 months will be the same. And questions, why we need to till? Topography nearly the plain, but we will see what's happened with our soil. Soil low in humus, about 1.7. Here, that is my footsteps. Footprint. We call ecological footprint. That is not ecological footprint. That's my footprint. After that, crusting of the soil. That is the reaction of the soil to this surplus moisture content. Okay, how to, for example, evaluate the damages? That's our article with Polish colleagues. And you may see if you have different types of soil tillage from conventional tillage with ploughing and strip tillage, which became very popular in the world. You may see different like big differences. Strip tillage and conventional tillage. In winter rape, winter with maize. Similar results were published by Dr. Benedictas Enkaus. Very similar in Lithuania. And that is wind erosion. You may see here dust here, and you will see the drainage place. And what is the big amount of soil? Dust, like as dust. Okay, some results from our investigation. Many years ago, nearly 20 years ago. You may see what's happened, for example, in plowed soil, we have about 9% of dust. That is bad situation. If you have only disking, 3.6 should be less than 5%. That is okay? Okay. 9% is not okay. And if you speak about the stability of soil structure, during, for example, 20 years, you may see quite big difference from plowing up to, for example, shallow cultivation and zero tillage. Every time we have impact, serious impact. So we may see here a statistic. So that is good result. That is solved problem. This problem not solved maybe during 2 or 3 years. That's 20 years, but we have really good result. This is from our, you may see here from the Polish results, from Poland, you may see a little bit too big amount of dust. Too big. Should be, as I mentioned, up to 5%. But you may see here the capacity, like we say, like a yield or soil water reserve in different systems. So tillage system, for example, in conventional and strip till, in different crop, for example, in winter barley and maize, that is 2 times, not a little bit less amount. That is very, very common problem because you know what the climate change affects our capacities or yield of moisture. And here we see some our results from sugar beet, some crop, and you may see that if you have a different intensity of soil tillage, mainly we have a bigger reserve of soil moisture. But according maybe 2 or 3 last years, distribution of precipitation is quite uneven. Some we have the shower rains, yes, we'll see what what happened maybe 2, 3 days ago. Some lakes in our fields, and in this situation, sometimes we have not found the significant differences between tillage intensity, not like as in this one. That is, you may see here a significant difference. Now, if you have quite big difference in precipitation, differences became not significant. That is no good. That is should be for us. That is big question. And to summarize, okay, you will see what to solve problems in the soil, physical problems. Sometimes it's not very complicated. Not so how to say. I don't I don't mention what is not very easy. Not easy. Sometimes you need special equipment. Sometimes we need the passion. Sometimes we need the energy. Yes, but it's possible to solve. But how to solve the problem? How to complete soil like as alive object, yes, with biota, yes, chemical properties. How to complete everything in one like as organism, yes, and in optimum should be relations, yes, optimal relation. How to make this? That's question. Thank you.
Thank you very much for your interesting presentation. And of course, problem is very large and problem is very actual, especially for farmers. And also when I came from Kedai today, also I saw those pictures, and of course, problem is real. And such problem is not only in Lithuania, this problem is in all over the world, yes. And therefore, such kind of experiments are very important. My question maybe is connected to his topic of first speaker. We fixed it that till 2016, tillage was a quite small part of all tillage systems. How is situation now? Maybe you know after in Lithuania after 5 years.
Very common and interesting question. Every time some of ministers asking me what is perspective, for example, so no tillage in Lithuania, and maybe 2 or 3 months I wrote an article about we have all statistics around the world. from different part, but from Lithuania not easy to find. But I have a good relation with Ministry of Agriculture and asked it, what about 200, that's about, I guess, up to 20% we have soils in Lithuania not plowless. And about 50,000 hectares of zero tillage, 50,000 from 2.5 million. I don't know what's percentage, but not much. But in comparison with German, for example, Switzerland, 3% only. That is quite modern countries with hills, with mountains. We have only hills, yes, but we have mountains and only 3%. That is the answer. I guess not much, maybe than 2%. That is perspective for Lithuania. Low of humus, you see problems.
Problems, yes.
Yeah.
Thank you for answer. Please, you are welcome to ask also. The students knowing everything in Lithuania, I think.
Okay, we will speak in open day.
Yes.
Thank you.
And now we will invite Zarina Livia from Institute of Agricultural Resources and Economics in Latvia, and the floor is yours. But this time for this side of this.
So I'm happy to be here, of course, and it's very good possibility to show also what we're doing here in Latvia. Today I bring with me results. I'm pity to say that only 2 years results, but results about influence of tillage system on soil penetration resistance in organical managed fields. And if to speak about organic farming in Latvia, I bring with me some data, and as you can also fix. So here we have organic area about 15% of all share years are 2020. And if to speak about organic arable land, crops, permanent grassland, and permanent crops, we are here, and we can see that it takes organic arable land about more than 50% of all organic area are arable land. And of course, similar other countries, problem is similar in every farm in our country. Soil quality parameters very hard depend on soil management system, and also we in Latvia looking for better methods, and we are also trying to use such like modern methods management without plowing. Yes, here is a lot of different literature data that minimal tillage is very good, that minimal tillage is good for soil quality and also sustainable management system. And also we saw from Lithuanian data that results really are good, but those results we can see only after a long period. And usually when we start with minimal tillage, results are not so good. In our farms, in my country, farmers are very interested in this minimal tillage systems, and they need data, concrete data, and they need also to understand if there are differences between farming systems, between conventional system and organic farming fields. And therefore, we got task from Ministry of Agriculture, and we got support to get some good or not so good results from real farms. And we managed investigations in two parts of Latvia, one part in Kurzeme side, using soil, Lewis soil loamy sand soils there, and other farm was here in Vidzeme side, and on those structure was sandy loam. You can see that both sides pH level very similar. Also, phosphorus content in soil quite similar, not very rich, but more or less similar. But as we can see, potassium level very differs, and we think that influenced very hard yields levels. But the humus content also quite good on such situation in fields if to look for soil quality properties. And of course, Latvia soils also similar. Lithuanian soils are very striped and very different. And of course, as already speaker Dr. Feza said, that every field needs special recommendations, and for all fields, general recommendations impossible. So here you can see the name of our project, Progressive Farming System as Basis for Environmental Friendly and Efficient Crop Production in Latvia. And one of the tasks of this project was to determine the most economical advantageous soil treatment of the system, evaluating the dynamic indicators of the soil and the ecological and economical benefit of each specific system. Of course, this title is very long and not very easy to tell about, but things that we're doing within frames of this project was measuring soil, this penetrometric resistance using penetrologger Ekenkamp company. And of course, we parallel made measuring of moisture. And moisture is important parameter, of course, and as we can see from all both places, this is nearest to meteo station data, and we measuring made in springtime and autumn time, and therefore I put accent on April months when we made measuring in the beginning of vegetation and in October when season finishing. And if to look for years, of course, there are differences, and we can see, of course, differences between both places. Those data we are using to find correlations with data of other managements. If to look for soil moisture, yes, farm 1, this is from Kurzeme side, farm 2, Vidzeme side. Of course, data depends depending on soil management system. System A is plowing, system B is minimal tillage of soil. Both places, this plowing was made autumn time, and also this minimal tillage also was made autumn time. And yes, if this only is for information, which kind of soil moisture was those times, and if to look for mathematic differences in moisture variations are not significant when comparing fields. However, the mean values are significantly different. Yes, here we can see this measure equipment that we used, and here we can see also some small data from our notes table. If to look for this penetration resistance, we can find quite interesting things in average depending tillage system. one farm, there were no differences between both systems, but in more light soils, difference was. And as in theory, as other scientists found already, when we using minimal tillage, this penetration resistance data are better for soil. Of course, we know that 2-year data is nearly nothing for agriculture, taking into account that different fields and different precipitations. But this question note I put like sleepy because was interesting findings that there are no differences between both soil management systems. All data together putting here we can see first farm. This is from Vidzeme side with more heavy soil, and here is soil from Kurzeme side with not so heavy soil. And yes, data variations between both soil management systems. This is plot A letter, and this is minimal tillage. And as we can see, differences depending farm we can see, and also differences between years. Here below are years. Spring, autumn, spring, autumn. So, and to summarize those data, 2 years data, I'm pretty realistic to give information for so short time, so short period. But according those our data, penetrometric resistance has changed minimal in both farms due to the tillage system, but there are also years when these differences are significant. And of course, penetrometric resistance variables vary from farm to farm. Here I would like to show you that differences between Vidzeme and Kurzeme side are very sharp. For example, Vidzeme side, May waves, this showing only beginning, but in Kurzeme side, spring cereals already you can see already green are. It's weak differences, but vegetation beginning nearly 2 weeks differs. So those are my small results. I'm happy for this possibility to introduce you what we are doing, and accent I would like put on the fact that those measurements we making on organic farming fields. And as you mainly, most of you knows, organic farming system not using any mineral fertilizer, and they not using pesticides. And from other literature, references, we know that it's also influencing effect of management system. Thank you very much for attention.
Thank you very much.
And somebody have the question? Please don't hesitate. If not, I have maybe not the question, but a comment. It is not the only one presentation, it is only my experience that our projects are too short. If we get money for 2-3 years, it is nothing for the nature. And to have the conclusions, the general conclusions. I don't know how it's in your country, but in Poland, the biggest project is for 4 years. And we have to buy, according to our regulations, the first year is for the to buy the equipment, and the last year is for the preparing the report. So we have only at least 2 seasons in the field, and it is not yet.
Actually, we using those data like pre-proposal for next project, and on such experience we have with experimental field concerning catch crops, and we made the first results, and the results were quite interesting for farmers, and they give it, farmer society give it acceptance. They give it time for us next more 4 years. And we are, of course, very happy because of possibilities.
Thank you. So the questions are? If not, now you see, it is not only the International Symposium, but intercontinental, because now I invite Tatiana Camila Zamora Ferrero to present her speech, and she came to us from Colombia.
Okay, good afternoon, no, morning yet to everyone. It's a pleasure to me stay here also representing the Colombia part. I'm from Universidad Nacional de Colombia, and I'm also representing the part of Polish side. So it's from University of Agriculture in Krakow. And our main topic is the relation between aggregate stability and pedogenetic factors in tropical soils, in this case from antisoils, alphisoils, oxysoils, and vertisoils. So as we already know, aggregate stability is one of the main physical properties, which is really important to explain most of the time our soil condition and also soil quality. And this is a fundamental property that depends of many factors and also from many dynamics in the soil. So most of the time we can include in these factors like pedogenetic processes, soil properties, also the anthropogenic influence on the soil. And of course, some exogenous factors like climate and also weather, and also the development of different societies in the places. And of course, there will be a big influence of microbiology and the clay content, clay type, and also from cations in soil. So this is an important property because with this one, we are contributing to explain how we can extensively make some ecosystem services, or at least to explain it and understand it better. And as I already mentioned, we use it too much as in soil indicator quality to assess the vulnerability of degradation of the soil. So from these reasons, our objective of this study was to determine the soil aggregate stability using different methodologies and to understand the influence of soil properties in the soil structure in tropical soils in relation with some pedogenetic evolution and factors. From our methodology, we collect, So from our methodology, we select different type of soils in different regions in Colombia. So we select some Orinoco regions, also the Caribbean part, and also from the Andean region, that is one of the most important in agriculture in my country. And we select 4 different types of soils, as I already mentioned, the alphisoil, antisoil, oxysoil, and vertisoil. And from this specific study, as we want to connect with pedogenetic factors, we collect the endopedons, most representative from BT, BSS, BO, and BW from the study. To measure aggregate stability, we use 2 different methodologies. One of them is the wet sieving method. It's a well-known methodology using one single sieve. And we use the index of main weight diameter. And from second methodology, we decide to choose optical microscopy and laser diffractometry. Is a methodology proposed by Dr. Bieganowski. And from that, we take a suggested index, the aggregate stability index. And from third index and try in order to compare our 2 main indexes before. So we also use a proposal index from Dr. Ratalal that includes the clay content, the silt content, and the organic soil carbon in organic soil. So, so we take in more soil properties in that index, physical properties. One, we can do our comparison between methodologies. So we realized that most of the time the index shows difference when we have highest aggregate stability indexes, like in the case of MWD. We have also a big important discovery that it takes also like a big stability from oxysoils. But when we talk about the lowest index stability, we find a two big difference between the methodologies that shows that our vertisol has the lowest index. But in the case of the stability index, taking into account soil properties like organic carbon and textural fractions, so we have like an oxysol has the lowest index of aggregate stability. So in any case, we make like the correlation between our methodologies, and we discovered that this methodology proposal by Dr. Beganowski, it's close related also with the index that when we compare with organic carbon and silt content and clay content. But in any case, all of our methodologies has showed a big correlated coefficient using Pearson correlation. And in all of the cases, we have values at least highest to 0.8 when we compare like wet sieving, for example, with the methodology of microscopy and laser diffractometry. Now talking about soil properties and the relation with aggregate stability, we find two different diagrams from multiple dimensional scale. And in the first one, in the number A, we decide to just include soil properties as texture and organic carbon soil, and some properties also like cations values. And in the second one, we decide to include also mineralogic results of the soil. So we can find few difference in the between of these two results. In the first one, we can check that as similar in the index, we have closest relation when we have alphisols and andisols in relation with the rest of the group of the soils. But when we include the mineralogy, we find a reorganizing of the results. So here we find that there are more similar results or more stable aggregate in the soil when we also include from the groups of oxysols when we include the mineralogy. So this is important to mention also, like in this first graphic, when we talk about andisols and alphisol, just one of the alphisols show a similar aggregate stability from the andisols that was considered the most stable aggregates in our study. And when we was checking also some of the pedogenetic process included on that, we also checked that they have similar relief, like in elevations between 2,200 meters above sea level and 2,600 or 800. So the temperature that they have in this region, in the Andean region, it's also between 16 and 18 degrees. So it's also a factor that they share between these three types of soils. And they have similar content or highest content in soil organic carbon. And the second, when we include mineralogy, it's easiest to check that the vertisol, one of the vertisol has the lowest, with the lowest aggregate index. As we can see here, is this vertisol. So they show the one of the most big difference between the main group. And when we was checking inside of the mineralogy content, of course, because of it's a vertisol, but with the difference of the rest of the soil, it is mainly has a highest quartz content and also a highest calcium content in the soil. And at the end, but not at least, so we can check also when we have this big main reordering. This could be also important to mention that we can find the big difference that makes like kind of minerals in oxysols, like hydroxides of iron and aluminum, that they're conferring to the soil, to this type of soil specifically, a highest aggregate into the particles. And the next figure, we can find easily this kind of difference, as I was saying, like this is one of the main groups, and they also have a similar texture content like in clay content, and also they share like a silty clay loam to silty loam texture classes. And they report also the highest values of organic carbon in the soil. But when we talk again about our last vertisoil, we find that also there is a big influence of the agricultural management in that soil that confers the lowest stability. Even if they have a big clay amount, they also have a big content of soil cations. And in the last, also we can find the oxysols, one of the oxysols and also one of the vertisols has the lowest, one of the lowest content by organic soil carbon, but in any case, those was not the lowest amount of also aggregation index. So, yeah, and with these results, we can summarize like most of the time when we are talking about some index and when we take some index from and make some assets, we most of the time just focus in the organic carbon content, or most of the time we just focus in the main properties, physical properties in the main profile or in the A profile. But in any case, when we go a little bit deeper, so there will be another kind of properties that we are not taking too much into account to provide kind of general recommendation from aggregation. To summarize, also is like the microstructural stability and the clay fraction composition of soils with different genesis attest to the spatial heterogeneity of the composition and properties of the mineral and organic aggregate compounds. And the high weathering and pathogenesis in tropical soils do not necessarily imply the high structural stability, as we was expecting from another previous results that show that when the soil is more weathering, most of the time they also have a better structural stability. In our study, so the sum is like most of the pathogenetic development was inversely proportional to the structural conditions that we have in our specific soils. So thanks so much. If there's any comment of that, thank you.
Thank you very much for your fundamental information. And audience, you are welcome for questions. We are not very active in giving of questions, specific maybe for this symposium, but I have one question. I would like to ask to show slide where table with different kind of lands. Was this one? Yes. No. Is this one? Yeah. So shrubs, forests, and shrubs, forests, volcanic, anti-soil and vertisoil. Can you say which kind of trees those different forests are?
We have big difference in trees because for the tropical conditions, we have a really high different species and big biodiversity. But in the case of our last vertisoil, it is in a zone when we have a highest production, like from many of agroforestry systems, and also most of the time we are having big sugarcane production, like in extension. So this is the reason, because this vertisoil also has big changes, because it was cropping during the last at least 25-30 years ago. So not in this region specifically. There are some, of course, in all Colombia we have a little bit of coffee, but not in that region specifically. We have more focusing sugarcane production in this specific area because of the temperature. Yeah. Thanks.
More questions?
Internet there is no,
Thank you.
but I would like
Thank
to
you.
inform that now, just in this moment, you have 60 participants in the internet.
So, and now, last speaker within this first session is Monika Tomowskiene from Lithuanian Agricultural Advisory Service. Yeah, welcome. And you would like to know how things going on here. She will tell about the applied innovation research and results information system special, and this acronym is CITRIS.
Administrator of project and CITRIS administrator. I want to introduce you the Applied Innovation Research and Results Information System. Short name is CITRIS. The history of CITRIS began in November of the year 2019, and CITRIS is a free open source information system that provides useful information for farmers on the results and the develop agricultural innovations carried out at national and international level. The users of CITRIS are researchers, advisors, farmers, and others who have a big interest in agriculture. The object of CITRIS is non-commercial research and innovation created in practice that have and can have a lower or higher significance for sustainable agricultural production. So what's the uniqueness of CITRIS? CITRIS disseminates information that has been evaluated by competent Lithuanian agricultural advisory experts. The process is fully automated. It means that I choose an evaluator, and for example, who will be evaluate this innovation. Then I choose a language editor, an administrator, and all the tasks they give from the system automatically. The data in the system is available in 2 languages, in Lithuanian and in English. Are published only this innovation that can be applied in practice. The possibility of receiving funding from EU funds is being assessed to each innovation. I will show where you can find it, and provides direct professional advice on innovation-related issues. So the CITRIS data of the results of applied research and innovation are provided to CITRIS by scientific institutions, farms, and other producers for specialized activities. You can fill 2 forms, practical or scientific. Before publicizing, as I said, innovations in CITRIS and all data is carefully evaluated by a competent specialist of the Lithuanian Agricultural Advisory Service. The purpose of this evaluation is clarification, novelty, adaptability, and relevance of a publicized information. As I mentioned, you can see is written all evaluators who can took place in all evaluation process. So, and CITRIS possibilities, you can find innovation by entering keywords. Also, you can subscribe to news and information about conferences, farm days, and so on. Follow events related to innovations and find farmers for collaborations. But this is only in Lithuanian version. And I want to mention that CITRIS from 15th of December of 2021 year is a state information system. I show you where you can find a short information about Tetris. Also, we have account on Facebook, so I invite you to follow us. And let's visit our system. We can choose English language, accept cookies. There is more information you can find in it. So, short information about us. You can find a written form and a short video film. Also, you can subscribe to news and information about events, contacts. Also, you can find events in the calendar. So, for example, the event for today. Oh, you don't see. Can you help me? Aš nežinau, žiūrėk, kodėl man nemato šitų. Reikia išjungti skaitę kalbą, ne? Excuse me. So you on this system, you can choose the two languages, Lithuanian and English. So I chose an English language. Here you can find short information about us and a short video film about the system, also contacts, new subscription and subscription and for events. Other useful links. Also, you can find a calendar where it is written some of the events. And the event for today, you can see this event. You can provide data. But firstly, you must register into the system. I am almost registered. So you can choose two forms for innovation data providing, practical and scientific. Near the forms, there are two short films with short video instructions how to film these forms. I can show. Oh. Something went wrong. Okay, then I show you a short film, how to can. Okay. The point is that when the form is open, there are some fields where you can fill the information, but it is all written what should you fill in, and after all filled information, there are some fields where can you put the video, the photos. And let's see how it looks on the system. You can choose all you want. So I chose this innovation. You can see all some information about this innovation, argumentation. So we can find here some photos, video links, some links into the research and contacts. So this is a short information about this system, and I want to invite you to publicize your innovations in it. Thank you.
Thank you for interesting information. Of course, we will check more deep. We'll go when we will more time. But how is the situation in this moment in your country? Are people very interested to open and to check and use it?
At this moment, from the beginning and to this day, this system are visited more than 85,000 times, and there is about 30 innovation in it. How to say? We want to show for all of visitors one new innovation for till the month, per month.
Please, auditorium, your questions about this system.
And if possible, I have a question. What does it mean that it is possible to receive money? So you have the funds for some small projects?
I will show. When there is an open calls for any support measures, you can find here a green check mark visible, and at this moment there isn't, but when they are, then you can find an information about this measure. You can find here contact persons where you have to find advisory for the measure. And if there are some questions, you can contact with them.
Okay.
Using this program, can also farmers to ask, do you give advices for special field or depending soil quality parameters? Can they get already any good advice?
In all the innovations, there are left contacts by the specialists and researchers who found this innovation. And if there are some questions, the farmers can communicate with them.
I mean, for example, Kęstutis knowing the situation in Lithuania in very many fields, and people who would like ask advice how to get away this water, he can ask to Kęstutis, for example.
At this moment, it's like that. If this Mr. Kęstutis will be published the innovation in this system, we can get his innovation, and we can have his contacts, and then farmers writes this innovation, and if arise some questions, we will have possibility to contact with Kęstutis and ask.
Thank you, Archie.
Thank you very much and for this presentation.
Thank you.
And it is my pleasure to summing up this session. I must say that it was some celebration, some holiday of soil physics. We had the presentations in whole scale, from micro scale to the full scale to the field scale. And it was only the first part of our meeting. Now it will be the coffee break, the poster session, and we'll come back for the presentations at 11:30. And thank you very much for all participants who are here and in the internet. Now it's about nearly 60 persons in the internet. Thank you very much and see you.
The Lithuania Agricultural Advisory Service is an impartial organization which has more than 400 employees working in 48 offices all over Lithuania and at the central office in Kėdainiai district. We are providing the following services: accounting, business plan preparation and administration, consultations on the questions of plant production, animal husbandry, forestry and occupational safety. We are organizing classroom and web trainings. Our uniqueness in agricultural market is that we have our own laboratory, where we are offering services of making soil, water, manure and other analysis. We are promoting the installation of precision farming machinery and devices to farmers. That is why we have a precision farming center in our structure. My name is Lukas Šapranauskas. I am a service provider and manager of Precision Farming Center. Our center services are for innovative farmers which are using or planning to use modern digital machinery on their farms and seeking effective farm results. At Precision Farming Center, we have two main services: plant production and animal husbandry. We are making digital variable fertilizing rate maps. With their help, smart fertilizing equipment knows what rate of fertilizers to spread in exact field place in order to get the optimal yield. Lithuania Agricultural Advisory Service gave us some tools for Fair Share DATS platform that we use every day. ICMIS is a national tool for monitoring and predicting pests and diseases spreading all over Lithuania. AGEBA, it is a farm management tool which contains animal husbandry, plant production and accounting models. If you want to know more about these tools, you can find information on Fair Share project web.
Vatata's Magnus University Agriculture Academy is where the knowledge about nature and technology is combined in order to step into a safer, cleaner, and greener future. Its community, inspired by the sustainability ideas, explores and discovers the possibilities to improve the world in a practical, meaningful, and innovative manner. The Agriculture Academy maintains regular relations with business and research institutes on all continents to enable the most empowering conditions for its student and researcher community for them to develop applied social, biological, and engineering innovations at modern laboratories of the Academy. Priority areas of science and research at the Agriculture Academy. Bioeconomy, biosystems engineering, sustainability of agro, forest and water ecosystems, impact of climate change. The demand for agricultural products is expected to grow by 60%, and every innovative idea counts. Vatata's Magnus University Agriculture Academy, for those passionate about nature and technology.
So welcome after coffee break for the second session of our symposium. And the first speaker, let's go quickly. First speaker is from my country. Welcome, Piotr.
Welcome.
Piotr Bartmiński from Maria Curie-Skłodowska University in Lublin, in Poland. So welcome, the floor is yours.
Okay, great. Okay. Thank you for the introduction. As announced, my name is Piotr Bartmiński. I'm Skłodowska University in Lublin, in Poland. My presentation will be about visible near-infrared spectroscopy for soil investigation in the field. So first of all, I would like to remind all of us, what is it, remote sensing? It's simply measurement of a composition temperature and other properties of an object, and by means of electromagnetic radiation. This radiation may be emitted, absorbed, or reflected by object that is measured. Of course, when we are talking about radiation, we have to remember that the spectrum of electromagnetic radiation is very wide and very differentiated in terms of wavelength, in terms of frequency, and some properties. In remote sensing, not whole the spectrum is useful. We use mainly UV, visible light, infrared, including near infrared, and microwave. What happens when radiation comes to active surface? Active surface may be vegetation, may be a soil surface, any material. This radiation may be transmitted through this material, may be dispersed by this material, and may be absorbed or reflected. Of course, these last two situations are strictly connected. The reflectance is of main importance, and this is the most interesting feature for me. Registering reflectance of material or active surface, we may observe special characteristic curves calling spectra, and these spectra or reflectance curves are characteristic for particular materials, and we may distinguish between particular substances
we can assess some properties of material even within one group. As we see, for example, pine trees have different spectra than deciduous trees. Here we have another example of this specific reflectance curves. Of course, these are model curves for particular materials. We can see soil with its specific quite flat curve. Of course, looking for this curve, we may observe some characteristic features like peaks, like baseline, many other features that allows us to characterize soil features. We use different sensors in remote sensing. Sensor may be active or passive. The difference is that active sensors emit radiation and measure back signal. Example of such sensors is, for example, radar or laser scanning. Passive sensors detect naturally occurring radiation, and for example, it may be satellite. It's quite important in terms of my presentation. That's why I am talking about it. Remote sensing data may be, or very often is multispectral or hyperspectral. There is a huge difference between these two kinds of data. Multispectral gives us discrete bands, isolated discrete bands, while hyperspectral data gives us continuous curve, allowing to assess many specific features of material. Sensors may be mounted on many different various platforms like satellites, like planes, UAV becoming more and more popular nowadays. And here we have our equipment, spectral evolution spectroradiometer. In this case, equipment is researcher hand, right? So it's this equipment that we used for the purpose of our research. And now we finally came to the project. Titled Application of Hyperspectral Imagery for Parametrization of the Growing Season in the Context of the Properties of the Soil Cover. A huge wide project financed by National Science Center in Poland. And within this project, of course, the main aim was the characterization of growing season, but one of very important aspects was characteristics of soil cover. I am soil scientist, so for me, soil is the very important factor. Of course, the most important is climate or weather conditions, but soil is also very important. For this project, we established 12 research plots in the eastern Poland. Some of them were arable fields, some of them were meadows, and some of them were forests. Within each plot, a net of 36 research points was established, and many times we visited every plot for 3 years. It was about 40 or 50 periods of measurements, and we collected a huge amount of data, mainly hyperspectral, but also data about soil moisture, soil temperatures. We collected soil samples for laboratory analysis, and we collected also spectra, reflectance spectra. And I would like to say something about this special spectra. The main goal of this part of our research was to answer the question, is it possible to measure soil properties directly in the field? Because spectroradiometry, we can see once again this spectroradiometer, And this technique of measurement is laboratory technique. So we are taking soil sample from the field, prepare it especially in a special way in the laboratory, and then we can measure its properties. But for me, it's not remote sensing, right? Because we have to collect sample and go to the laboratory. So the idea is to measure soil characteristics directly in the field. But of course, we expected many problems with such measurements. But I think that's science simply, right? Finding problems and trying to solve them. So during the 3 years of measurements, we collected a huge library of soil spectra in the field. Of course, we selected only these areas that were arable fields because this is the only situation when we can observe bare soil. In other cases, we had meadow or forest, so not bare soil. And in these cases, we could observe soil. The slightly surprising for us was the very short period of time in which we could measure bare soil. I mean, a short period of time in which we can observe bare soil. Because in the case of wheat and in the case of, how to say it in English, rapeseed, it was only about 2-3 weeks per year when bare soil was observed. In the case of corn, it was quite longer, about 4 weeks. But it's not long period, right? It was quite surprising for us. We used 2 spectral evolution radiometers for measurements, and the measurement was made not by the direct contact, but we collected spectra from the height from 30 centimeters up to 1 meter from the soil surface. We collected a huge library of spectra. Of course, here we have model average spectra for each of our research plots. Of course, these spectra are carefully prepared because raw data, unfortunately, look like this. We can observe many noise on this data, and this is the main difference, in my opinion, not only in our opinion, this is the main difference between laboratory observations and field observations. In the laboratory, we can analyze spectroradiometry using control conditions of moisture, of light. Sometimes, or very often, in the laboratory, we use spectral radiometer as an active sensor. I mean, it is equipped with own source of light, tungsten light. And in the field, we don't use own source of light, but our measurements are based on ambient light. That's why we registered quite huge amount of noise, especially in some ranges of spectrum. So spectra needed to be pre-processed using several techniques. The most popular, of course, was moving average, but also it is not mentioned here, but we have to remove some parts of spectra when noise was registered. After pre-processing of spectra, we made calibrations, and finally we created prediction models, and then we carried out evaluation of this model. Of course, we used soil data. We chose organic carbon content, total nitrogen content, and soil texture. Here we have characterization of particular plots, its average content, and our models were evaluated. When we are looking at this R-score parameter, we can see that it's not very high. It is not very high, but once again, we have to remember that this is field study, not laboratory study. If it's 2 minutes, okay. If we see such results in the case of lab study, in my opinion, it's no good. But if we have such values in field study, in natural conditions, we found it as satisfying. We created prediction maps in relation to the content of clay, nitrogen content, and organic carbon content. Unfortunately, these maps, because of the quality of the models obtained, these prediction maps are not very useful directly in, for example, precision agriculture, but may give some information overview of particular fields. Most important issues with remote sensing of soil cover on the basis of our experience is short period of possible measurement, mentioned by me earlier, surface differentiation of soil. I mean that the surface of humus horizon is completely different than humus horizon itself. Because of some changes of some flora on the surface of the soil. We have structure on the surface of soil, aggregates. We register mixed pixels. I mean, within one registered pixel, we have information, we have different information mixed together. Very important issue is changing light conditions because we base on ambient light. And very important thing is changing and discontinuous moisture of soil in field conditions. Here we have an examples for this is spectra from one field with different moisture conditions. Also in PCA analysis, we also confirmed that moisture or drying effect is of very high importance in collecting spectra. Here we have an example of mixed pixels in the case of rapeseed. Here we can see structure on the surface of soil, mixed pixels once again, and this is mentioned by me differentiation of soil surface, right? We have soil humus horizon, but surface of this horizon is completely different. Future challenge for our research is supplying models with vegetation data because we observe that many soil features are related to vegetation spectral response. We are scanning our soil samples in lab conditions to compare lab spectra with field spectra, and we observed that implementation of soil temperature may improve our models. Thank you for the attention.
Thank you. We give you more time because we expect only a few questions to colleagues. So if you have any questions to speaker, please. Oh, please, lady first.
Thank you. I would like to ask which kind of this vegetation do you think will be most important for this model?
Sorry,
If you turn slide back and in your stop. Conclusions. Yes. Next for future. Next slide, please.
Next slide.
Yeah. for future, you challenges, yes.
Challenge.
Yes, yes, and my question is, which kind of vegetation data do you think will be most important to put in model?
What type of vegetation data?
Yeah,
I mean,
biomass or area or
no, I mean implementation of models with vegetation data. We collected huge amount of soil spectra, bar soil spectra, but we want to implement also vegetation spectra registered with soil spectroradiometry, but also registered with UAV hyperspectral camera. But it will be spectral information, not vegetation information about, I don't know, but spectra, so vegetation spectra.
Last question, sorry, last.
Ask you to change the slides to the photo with the plants in the row. No? Oh, okay. You measured from different heights, from 40 centimeters, 1 meter. What was the pixel, and were you able to measure between the rows?
This picture is not the example from our spectra collection. This is especially taken by me as an example of the situation in which measurement is invalid. Because 1 pixel, I may go back to the slide or not, 1 pixel collects data from this plant, from this part of bar soil. Here we have difference not only in moisture, but also in texture. Because it was in the slight slope, and here we have sand, and here we have silt. So 1 pixel collects data, could collect data from the plant, from the sand, and from the silt. So that's why I presented such picture, to show that it is very, very important to have know-how about field measurements. It's not so easy as lab measurement. I took sample, took a spectrometer and have data. No, here we have to think a lot.
Okay, thank you. We thank Piotr Bartminski, and we invite the next presenter, Michel Bestiak. Floor is yours.
Hello everyone, my name is Michał Beczek. I am from Institute of Agrophysics, Polish Academy of Sciences in Lublin, Poland. My presentation is a continuation of water erosion process in microscale, which was showed by my colleague Rafał. And the topic of presentation is splash phenomenon on slope measurement methods for the characteristics of ejected material. A quick reminder, what are the effects of splash? It could be the transfer of soil material over different distances, any consequent is loss, the breakdown of soil aggregates, the changes of soil structure, surface structure, and microcratering, and the spreading of bacteria, fungi, and contaminants with the ejected particles. In contrast to my colleague Rafał and microcaterology and soil deformation, the object of my research is the ejection of particle aspects, which are ejected and transferred over different distances and different directions. Generally, 3 types of particles are ejected during the splash. It could be soil particles, water droplets, and particles which are the mixture of water and soil. For the purpose of the description of this aspect, the ejection of particles, with my colleagues, we are using different methods and techniques. For example, we've used a microscopic splash image to analyze the traces of splash particles on blotting papers. We have also used a high-speed imaging technique with cameras for the observation of splash and description of ejected particles, and also for the parameterization of crown formation on the soil surface. We have also used a splash-capped splash cap for a description of ejected material, taking into account its division into the splash solid phase, which was soil, and liquid phase, which was water. The combination of high-speed imaging and splash cap allow us also for a determination of various techniques for the calculation of kinetic energy of two-phase soil splash material. And in our latest work, we have used a deuterium labeled water and IRMS technique to define the origin of the splash water, generally to find out from which that the splash water comes from the impacting drop or the soil sample. So what were the reasons for undertaking that topic? First of all, the lack of quantitative and qualitative description of the splash phenomenon. Next, the needs for the development of computer mathematical models based on the physical description of splash and water erosion. The possibility of modeling the spreading of pathogens and pollutants transferred with the soil particles, which was very important for me in the case of already submitted project proposal. And also the development of research method for the calculation of energy balance of a single drop impact on soil surface. Our measurements are based on a single raindrop impact, which provides a basic mechanics of splash and could be useful as an indicator of soil splash erosion. Those results are also important in the case of spreading the bacteria pollutants with the ejected particles, and also very important in case of detailed model for data for models. In our measurements, we also take into account many factors influencing the splash. It could be the soil properties or parameters describing the impacting drops. But today I would like to focus on one of the external factors, which is the slope incline, and present some measurements methods for the characterization of splash on slope. The aim of my study was to present the possibilities of the splash cap measurements and high-speed imaging for the characterization of splash on slope caused by the single drop impact, and the research was intended to relate to the mass and proportions of the ejected material and to the quantities describing the ejected particles. From a general methodology, first of all, we have used soil samples differentiated in terms of texture, which were moistened based on the pH characteristics. We have included three types of slope inclines, and the water drops were dosed by a water dosing system mounted on vertically moving platform, which allow us to modify the kinetic energy of falling drop. So here is the first methodology, the splash cap measurement. In this case, our aim was determination of the mass and proportions of the splash material during the splash on slope, taking into account that the splash material is solid phase and liquid phase. For this purpose, we have used a modified splash cap, which was divided into two parts for upslope and downslope directions. Generally, after the splash, the single drop impact on soil sample, the ejected material was collected on splash cap walls and internal trough, and immediately weighed on laboratory scale to define the total mass of ejected material. Next, the cap was air dried, and after a few hours, it was weighed one more time to define the mass of splash soil, and the differences between both results allow us to calculate the mass of splash water. Here is the example of results for the total mass of ejected material for three soils. Generally, the highest mass of total material was obtained for the soil with the highest amount of sand fraction. As it can be seen from the graph, with the increasing slope inclination, there are visible different trends for soil. For one of the soil, the decreasing trends with increasing slope inclination is related with the low role of upslope direction, where the material is mostly ejected downslope. And for two different soils, the increasing trends with increasing slope inclination is related with the mostly with transferred ejected water from the impacting drop. Here is another example result from those measurements for one of the investigated soils. The upper graphs present the distribution of collected material for upslope and downslope directions, and the lower graphs present the mass distributions, taking into account the splash soil, the brown color, and the splash water, the blue color. Generally, some conclusions from those measurements. The change of slope had a variable influence on the measured quantities, which was related with the texture and cohesion with the soils. With the increase of slope, the splash material was mostly ejected in downslope direction. And what's more, the ejected material consisted mostly of water. This occurred for material ejected both upslope and downslope. As you can see below, those results were already published in PLOS ONE journal this year. The second methodology was a high-speed imaging. In this case, our aim was a quantitative and qualitative description of ejected particles with respect to the number of ejected particles and their characteristics like the size of particles, ejection velocity and angle, and the displacement range. In our measurements, we have used 3 synchronized phantom mirror cameras. The registered images were processed in Dynamic Studio software, and next they were combined with particle tracking velocimetry to track of ejected particles in space. Here are some example images registered by high-speed cameras. The left image presented the raw image of splash on haploid pluvial soil, and the right image presents after the graphic processing process. Some observations for all tested soils: the number of ejected particles decreased with the increasing slope, and in each case, more particles were ejected downslope. The registered images were also combined with PTV, which allow us to define the flight trajectories of the splash particles. On the basis of determined trajectories, it was possible to analyze the velocity and angle of ejection, and also the displacement range to which the particles were transported. Generally, it was visible that the increase of slope had a influence on the measured quantities, but I would like to say that this study is still in calculation and will be published maybe this year or next year. At the end, I would like to say that the presented methods are not the only one, and there are many more for the description of splash on slope. Thank you for your attention.
Thank you very much. Questions, please. No questions? I have one question. Is it the standard size of the individual water drop, or does it matter? How big is the drop?
Is it important?
Is it important?
Yes, it is very important. In our case, we use big size of impacting water drops, but we also change the range of the size of drops to even 2 millimeters. And the influence of this size is really important for the splash and the number of ejected particles and the total mass of total splash mass.
And the second question, how do you think, how much these standard size drops are in the rain event?
Generally, in natural rain events, the mean size of the impacting drops is about 3 millimeters. Our drops during our measurements were slightly bigger because we also take into account to relate to throughfall phenomenon, which means the drops falling down from the trees. And in this case, the drops are really bigger than in a normal rain event.
Thank you. Thank you. Okay, so thank you. Well, once again, thank you for your presentation and welcome on the floor. Next speaker, let me read Grażyna Kadzina. Sorry for my presentation. Pronunciation, sorry. Welcome.
Hello, ladies and gentlemen. I'm Gražina Kadžienė from Institute of Agriculture, Lithuanian Research Center of Agriculture and Forestry, which is our main building is located in this village. And after lunch, we will have possibility to see our soil physics laboratory. But as you can see from my topic, today I will talk not only about soil physics, but also as a problem which may arise with the different tillage, especially minimum tillage systems. Okay. As you know, minimum tillage is the save time. We use the less gasoline, which is very important, and we can faster do drilling or other job, but it also minimizes soil erosion, which is also very important. But sometimes it may cause some problems like topsoil compaction. As you can see in this picture, the standing water we often see in the fields where minimum tillage is applied. And of course, the other key problems arising together with the minimum tillage is pest infestation. The weeds or diseases, also insects. In the picture on your left side, you see a lot of weeds left after drilling, after direct drilling. And what is important that in this picture, the weeds are of the same family as cereals, is monocotyledonous weeds, which are quite difficult later to control them in cereals. And it may become a big problem if you use year by year the minimum tillage, and especially if you have a cereal-based crop rotation. And the other problem, diseases, especially soil-borne diseases. But in this presentation, I will show some data on grain contamination by fusarium fungi. Therefore, I show the picture of fusarium head blight. This disease is not only results in grain reduction, but also grain contamination, which finally contaminate grain by mycotoxins. This, oh, nothing. Okay. I will show you some results from our long-term experiment, which has 5 different tillage systems. Deep and shallow plowing, also shallow and deep harrowing, and direct drilling. This experiment is established in a crop rotation of 5 different crops. 3 of them are cereal crops: spring wheat, spring barley, and winter wheat. Also field pea and winter oilseed rape. Also, this rotation includes some cover crops. We have white mustard after spring wheat and spring barley, and white clover after winter oilseed rape. These cover crops were established in a very simple way using a fertilized sprayer. White mustard we established 2-3 weeks before the harvest. If we have enough moisture, soil moisture, and then we can use this method. And after harvest, we already have some seedlings in the field, which not allowed to germinate many weeds. And the white clover we established in spring after the regrow of winter oilseed rape, also the same method. Here you see a picture of in one how the field looked after 1 month after harvest. In one side we didn't have a white mustard, and other side with white mustard. On the left side, you see how many weeds we have in direct drilling tillage, where no white mustard was established. And let's see some results on it. As you can see, white mustard reduced from 2 up to 3.5 times weeds in a post-harvest period. And at this period, as you know, especially when minimum tillage applied, when you just leave the field after harvest, weeds start to germinate, and sometimes they produce seeds, and thus increasing soil seed bank by seeds. And some soil physics. Here also, as you know, soil bulk density is a key parameter which shows the soil compaction. There we will talk only about arable layer, because usually from tillage we can have compaction at the topsoil, as I mentioned before. And there we see that in a direct drilling, the soil compaction was quite high. It exceeded 1.6, which is normally a critical limit for loam soil. And this figure also clearly shows that the establishment of white mustard tended to decrease the bulk density, and it was significantly decreased for both plot treatments. The other important parameter is the total porosity. As you see, it was results were very similar, like with bulk density. The also total porosity was tended to increase by using the white mustard, and was significantly higher for both flowing treatments. And what is also very important, that the white mustard reduced grain contamination by fusarium fungi, and they also had some significant results. The other cover crop, as I mentioned, was the white clover. Here you see picture in approximately 3 weeks after harvest, where we already have a carpenter of white clover and no space to germinate for anything. And on the right side, where no cover crop was established, you see a lot of weeds, also volunteer oilseed rape starting to germinate. And a huge impact of this cover crop we can see at post-harvest period. It's really reduced very much the regermination. It's up to 18 times. And again, bulk density. Also the same tendency. White clover also tended to reduce bulk density, and it was a significant decrease for shallow plowing. The same as total porosity, it significantly increased the total porosity for shallow plowing, and for other treatments as well, was tendency to increase this parameter. Again, grain contamination was also lower with using white clover. After 8 years of cover crop management, in this period we had 5 cover crops. There were 4 white mustard, and 1 year was with white clover. So after this period, we have some promising results on nutrient content. As you see, the cover crop tended to increase the phosphorus oxide for all tillage treatments, and was significant for both plowing treatments. It also increased the cover crop also increased the it's almost the potassium oxide, what is also looks very promising. And what is very important, after this 8 years period, we already have some increase in organic carbon. And in these data show that a significant increase was in direct drilling, but also in other treatments, we already can see some increase. If to say after 2 years of use of white mustard, we still had some even lower amount of organic carbon after the use of this cover crop. But in longer period, as you know, for organic carbon, for humus, we need time. So after 8 years, we already have these results. And the message, what I would like to bring you with you from this presentation is that cover crops are, I think it is our future in this. If we will continue this way with reducing soil tillage with minimum tillage, it is. I think it is. It will be a key tool for which may help us to solve problems arising with this system. And of course, we have to think about our crop rotation, what crops we have, what cover crop how we choose. It should be of other family and so on. But I think it is it's quite promising tool. That's it. Thank you very much.
Thanks for the presentation. Any questions from participant? I check also chat. There's no question from online group. So I have one question to you about the bulk density of the soil. You measure layers 0 to 20 centimeters, and the one system gives you result 1.7. It's very high. If I could remember from literature, so maybe this is the density where even a root system couldn't growing.
Yeah.
How is possible?
Yeah, actually, thank you very much for the question. Actually, I should mention you that usually when we measure these physical properties, it's in autumn or in the spring. When I mean, it might be also after the harvest. So naturally, of course, it's the bulk density is higher compared to when we just drill the crop. But also, it very much depends on soil moisture, and if it's lower soil moisture, of course, we will have a slightly higher bulk density. And yes, I agree with you that it is limiting crop growth, but if it's for example after harvest, so then it's not so important for the crop. But just to compare differences between the tillage treatments. It's possible.
I hope the average bulk density from.
Yes, of course, it was the average. Yeah.
What is standard deviation? Do you know some data? No.
Okay, well, not this side. You can see it's not a standard deviation, but it's a standard error. You can see on this, yeah, and I don't know how to, yeah, but okay. If you look, yeah, not all the data were above this 1.6. It's actually for loam soil is usually 1.663 or like it's critical, I'd say.
Thank you. Yep. Thank you, Grażyna. And we invite next presenter, Kalvis Berģiņš from Latvian University of Life Science and Technologies. So, floor is yours.
Okay. Hello, my name is Kalvis, and I am from the Latvian University of Life Sciences and Technologies. And I will be talking about the influence of the type of tillage on the topsoil texture. So the problem is that most of Latvian soils, roughly 2/3, are formed on moraine loams and loam deposits. And these glaciogenic bedrock is the most common in moraine hills and embankments, including the place we will be looking at today, Gulbenes region. So as you can see, the surface of this field is covered in moraine, and starting from very small, going up to very large rocks, which are a problem when trying to sow and grow any crops. And the solution is by using the reversible power harrow, which works up to 28 centimeters, and the working width is 4 meters. And it operates on the principle that it is a very sturdy frame, which works in reverse by lifting these moraines out of the ground and putting them in first, and the plate on the back then sort of covers these rocks with the topsoil layer, leaving all of the moraine and the rocks in the layer between 18 and 20 centimeters. And these harrows have multiple functions. They can make rows. They can flatten the field, and also it's possible to attach these harrows to sewing machines in order to after this process sow the seed directly. Here is a video of this power harrow working, and there of course are some positives and negatives of this process, and the positives being that all of these preparation functions can be done in one trip. There is no plow sole, no extra hardening from this. It is very fuel economic, and it leaves the rocks on the field, or in other scenarios where it would be that moraine would have to be transported off the field to the side, and that also takes up space. And the negatives are that this process is very slow, the maximum speed being only 5 kilometers per hour. And it works in relatively shallow depths, which means that if you were to plow this field, the moraine could potentially be brought back up, and this process would have to be repeated. So the aim of the study is to determine whether the amount of the file soil fraction in the root soil is not reduced when using this reversible power harrow system. And the hypothesis is that this tillage system, with its potential complications, can cause the coarser textured coarser texture in the root zone, which disrupts the capillary system, reducing the water supply to the crops. So the methods used were by digging plot holes up to depths of 31 centimeters, and in 10 replications, each of the tillage systems were analyzed. And here we can see that on this side, by using the plow system, it's very uneven. It makes a wave, and also the coarser fragments also are on the top soil, which causes problems. But after using this power harrow, you can see that the finer particles of the soil actually even out, and as predicted, all of the large moraine stays in the 18 to 21 centimeter region. So the conclusions is that the percentage of fine soil particles in the upper 18 centimeters is much more even when treating the soil with the reverse power harrow, as opposed to the conventional plowing system. Most of the coarse fraction has actually fallen below 18 centimeters, and the fine graded losses are not critical. And the data shows that the reverse power harrow system allows to successfully rearrange the topsoil for improved root conditions. And additional gains is that in the first picture, it is seen that on this side where the power harrow has been used, there is very little plant mass left, as opposed to the plow, which left a lot of the plant mass on the top soil. And the negative, of course, was that stones larger that are than 25 and 30 centimeters do not get affected by this power harrow and sort of get thrown out to the side and still have to be picked out. This is the staff that was involved. The farmer, which let us use his field, and he was actually the initiator for this project. One of our researchers, researcher assistants, and of course our very enthusiastic project manager. And of course, the best regards from our professor, Aldis, who participated greatly in the research of this project. Thank you for your attention.
Questions, please, from the audience. I look for the chat. No one? No one. Ask about this. If no questions, I have. Concerning terminology, what do you mean soil texture and what do you mean soil aggregates? Is it different?
Well, um,
Yeah. Granulometric compound, if you understand.
yes, well, yeah, well, the structure and aggregates and are the same, but I guess I made a mistake, and it was meant as the granulometry is the finer and coarser particles.
Okay, I think you present soil aggregates composition with different size in millimeters. But what was the soil texture? Is it was sandy loam or it was sandy soil?
It was sandy loam.
Sandy loam. It was light soil. And one more question: how do you think is this power harrow was designed for the field use or for, let's say, greenhouse application?
I think it was designed for the field, but it's not meant to be used every year. It's like more of a, as I said, it works better with the minimal soil treatment because you do it once and then you don't have to repeat it. So yeah, I think it is for field use.
Okay, thank you very much. Thank you.
Okay, so next speaker is invited, Mikola Conchera, sorry, and please.
Good afternoon, everyone. Dear colleague, today I would like to present not so very generally results, but it's very good idea for future. And my topic is the relationship between soil agrochemical properties, macropores, and water stable aggregates under different tillage. About introduction. My research aimed to quantify the relationship among soil chemical properties, I mean soil organic carbon, total nitrogen, total phosphor, total potassium, and of course macro parameters and water stable aggregates in topsoil layers under contrasting tillage, convection tillage, and no tillage in combination with different rates of mineral fertilizer and plant-reduced management from long-term field experiment of Cambisol in central Lithuania, Lithuanian Research Center for Agriculture and Forestry, Institute of Agriculture. About material methods, you can see the picture how to make measurement with X-ray computed tomography analysis of soil samples in Institute Agrophysics, Polish Academy of Science Laboratory of X-ray computed tomography in October 2019. We've using device with the samples size 15 millimeters in diameter and 50 millimeters in length. And with device Nanotom 180S. Next method, it's using with wet sampling apparatus. We collect samples from different treatments, and after we saving with using rage saving shaker, it's air dry soil for especially fraction 1-2 millimeters, and after we have some determinate water stability aggregates from soil depth 5-10 centimeters by wet saving apparatus, LCAM. About results, we stable to show soil agrochemical properties in relate to different soil tillage, fertilization, and reduced management. About soil organic carbon content, with the tillage amount from 7.55 to 8.72 gram kilogram in convection tillage, from 9.04 to 9.46 gram kilogram in no tillage. The soil organic carbon average across reduced and fertilization was 10% higher in no tillage than in convection tillage. About soil total nitrogen contents within the tillage, the 0.73, 0.88 gram kilograms in convection tillage and 0.821 gram kilograms in no tillage. Total nitrogen average across reduced and fertilization was 15% lower in convection tillage than in no tillage. Next, soil total phosphorus content with the tillage the 0.35, 0.42 gram kilogram in convection tillage and 0.41, 0.56 gram kilogram in no tillage. Total phosphorus in no tillage was 19% higher than in convection tillage. About soil total potassium content with the tillage, the 4.25, 4.86 gram kilogram in convection tillage and 4.25, 4.79 gram kilogram in no tillage. Potassium average across reduced and fertilization was only 2% lower in no tillage than in convection tillage. Next result to show effects of tillage for water stability aggregates, what was statistically significant for tillage. You can see in convection tillage more lower than no tillage. But except for reduced and fertilization, these are not significant. Water stability content average across reduced and fertilization was 48% lower in convection tillage than no tillage. The content average across tillage and reduced was 9.8, about 10% lower in treatments with fertilization and without fertilization. About result macropores. You can see this picture. It's X-ray tomography. What we look at the 3D visualization of soil macropores at 5-10 centimeter depth in different soil management without mineral fertilizer application. A, convection tillage reduced removed. It's 2.69% macropores, its total volume. B, convection tillage reduced returned 1.97%. C, no tillage reduced removed 2.35%. And D, no tillage reduced returned 3.32%. Next picture to show 3D visualization of soil macropores the same depths in different soil measurement with mineral fertilizer application. A, convection tillage reduced removed 1.94%. B, convection tillage reduced returned 1.60%. C, no tillage reduced removed 3.37%, and D, no tillage reduced returned 3.73%. And next table to show matrix of correlation among soil agrochemical properties, volume of macropores, and water stable aggregates. The highest influence of soil organic carbon increase demonstrate of fine science macropores. You can see in table. Next, total macroporosity. The total nitrogen significantly and positively correlate with many factors research. Soil organic carbon, phosphorus, fine science macropores, and total macroporosity. There are influence of potassium and soil organic was negative. Increase in fine macropores with highest potential of enhanced nitrogen total in this study. Increase in my class of macropore did not relieve positive effect on potassium enhanced within of the 0-10 centimeter layers, the soil organic carbon and nitrogen total positive correlate with soil water stability aggregates and how I said before, nitrogen with water stability aggregates. Total phosphorus accumulation if there can be so significantly positive responsive to increase of volume of fine science macropores. You can see the total volume macropores, phosphor positive correlate with water stability aggregates, total potassium content correlation with other in this researcher were not significant, and potassium negatively correlate with water stability aggregates. The relationship water stability with medium size macropores, fine size macropores, and total volume macroporosity, while relationship with coarse and very fine size macropores, they're insignificant. This is relationship with coarse a lot of size doesn't have some specially volume. It's 0. And before we doesn't have some, we have insignificant correlation. Conclusion, soil agrochemical property, soil macropore network and water stable aggregates averages across residues and fertilization. The 10% for soil organic carbon, 15% for total nitrogen, 19% for total phosphorus, 37% for total macroporosity, and 48% water stable aggregates, higher in the no tillage than under convection tillage. Next, content water stable aggregates and macroporosity tended to decrease in the following order: no tillage, return resumed, no tillage, removed resumed. Next, go to convection tillage, removed resumed, and convection tillage, returned resumed in both fertilization. This shows that resumed and tillage had effect on macroporosity and water stable aggregates differently. Intensive anthropogenic activity occurs and decreases water stability of aggregates and thereby reduce the macroporosity in 0-10 centimeter layers. And next, soil organic carbon, total nitrogen, total phosphorus had a positive direct effect on the formation of macropore network and water stability aggregates, since our results are largely based on correlation. The mechanism on interaction between soil agrochemical properties, water stability aggregates, and soil pore formation need to be further explored in future study. And I would like to set many thanks for Lithuanian Academy of Science and Polish Academy of Science for the financial support for my study visit to Department of Meteorology and Modeling of Agrophysical Processes, Institute of Agrophysics, Polish Academy of Science, Poland in 2019. Thank you for your attention.
Thank you, Mikołaj. We are on time, so we have few minutes to give a questions to colleague. Any questions? So maybe I ask you about something. Why you focused on macropores in this investigation? Only on macropores.
On macropores, because it's macropores, it's look like indicators. You can to look at. No, I can to show it if you look at my picture, different between this picture. Wait, sorry. Oh, sorry. This is picture where 3D view visualization. This you can to see what different between convection tillage and no tillage. This very nice to show what is texture. If you have more macropores, it's very how to say to show this is nice stability with all construction soil. It's better. And next, what for me interesting, because in Institute of Agrophysics in Lublin, I found very interesting new method to how to check how many macropores, and I can to show it. What difference between some size of macropores? I can look at and not only macropores, but for me very interesting macropore because it's how to for water, very nice way to go in, and how to communicate it different macropores. No, you can see. Look at this. If you this is no tillage. You can see it's a lot of it's look like one organism. If you look at here, it's higher. You don't have some specially a little bit in this. You can not look like communication between one macropores.
Something because you took samples on the end of vegetation season or during the vegetation season. What was the time when you
only one time?
One time?
Yes, because I have only not have a lot of time to go in Poland and made a lot of samples. I have only 2 internships and.
Yeah, but the group of macropores could be changing during the vegetation season.
It's very interesting. I have idea, and I communicated with my colleagues in Polish Institution of Agrophysics in Lublin. He said very interesting idea we have for communicated Lithuanian and Polish for future. I think maybe we continue to work with method.
Know what happened with macropores during the season.
Yes, for me very interesting. And
iron, but also water is important.
Yeah, and not only for period with vegetation. I think need to look at how to change after winter, because in winter a lot of frozen. How to change? It's good, better was after freezing or not?
Yeah, question. What do you need macropores? What size of macropores you need?
Macropores.
Do you need deep cracks, let's say, or cracks are not included as macropores?
No. It's very interesting. Thank you for question. Very interesting question. But my idea it's only look at not only cracks, but usually how to communicate it. A lot of macropores, not each, how to together to work. Yes, but I think it's yes, but not only methodology this is problem, because this is picture to show it after cutting, because when we have samples we collected from soil, metal cylinder, something pressing, and after we only to prepare this picture to show it only without this tracking.
Important when you show your data is to explain what do you mean under macropores. It's very clear, should be defined, because the questions arise, I think, due to this reason. What do you mean macropores? What size of it? Diameter? Diameter.
No, I use it by Brewer. Have some special methodic for how is it to present it with macropores, and have some specially classification for coarse, fine macropores.
Show you the table.
Table.
Table 1 with statistic results.
Okay.
Oh, you have a good.
Well, this table shows different macropores.
Okay, but we ask about diameter of this group of macropores. Diameter, you need to put.
I don't remember. I can't to see it now because in my brain not.
Okay.
But this is it's. Yeah,
okay,
but you can to find it in my article.
Yes, this is very good answer.
Yeah, but I can see this different two size of macropores. I am using classification Brewer.
Very good. It will be good to add some. No, very good.
Yeah.
We are going to read your papers.
Okay, thank you.
Okay, next presenter is Jonas Volungarich. Yes. So Jonas.
And please don't be afraid about questions. Next. Yes. Okay. So
and the last one is the field.
I would like to present to you some of the results of the research which were obtained in cooperation with Vilnius University and the Lithuanian Agricultural Advisor Service. Laboratory analysis were performed in the laboratory of the Lithuanian Research Center for Agriculture and Forestry. 9 farms area were selected for the research which are localized in different Lithuanian agroclimatic and geomorphological conditions. Undulating moraine plateaus, undulating moraine lowland, slope of the river valley, moraine plain, and moraine hilly upland. The results of the survey were tested in 23 other farms in different regions of Lithuania. It was a practical study. It sought to optimize soil cover research by adapting unmanned air bicycle. The main focus was reducing the number of laboratory analysis, selecting the optimal test point, and determining the soil organic carbon and relative soil moisture content using remote sensing. Therefore, during this presentation, we want to share your practical experience that could be useful to other researchers in conducting similar research. The work was mainly done on the ArcGIS platform. Geodatabase format was used. Special analyst was performed using RGSI and special analyst tools for raster analysis. AGSI algorithm have been developed to allow rapid analysis and classification of rasters, as well as to automate the selection of points of laboratory analysis. As a result, the raster analysis process time of the soil cover area was shortened from 24 hours up to 19 seconds. Principles of the work process. The orthophoto image was captured at a height of 120 meters using a fixed wing unmanned area bicycle and a lens with a focal length of 15 millimeters. A GIS software was used to create orthophoto raster. RGB raster is created and its generalization is performed with ArcGIS desktop software. RGB spectrum data is read and classified. Generalization of raster data is performed. Typing and raster classes based on laboratory data. The results of the research raised more questions than provided answer. The main question is whether the soil cover classes identified during raster typing can be assigned specified soil properties determined by laboratory analysis. Why the results of the analysis and the relationships between RGB spectral data and soil properties are so different? Why do cardinal difference in the analysis of the same properties occur at different study site? The answer is complicated and ambiguous. As you can see, the correlation between the same soil parameters is very different in different study area. Such results presuppose an assumption that next results may not be consistent with the hypothesis raised at the beginning of the study. The main hypothesis of the study is that soil organic carbon or humus soil moisture strongly correlated with the relief, and the surface relief is directly related to the distribution of RGB spectral values. Therefore, we are expected to obtain a more or less strong correlation in all study areas. However, the aim of our study is determine how the indicators correlate with the value of RGB spectral bands. We see the same correlation problem when analyzes other soil cover properties. The correlation between the humus and RGB spectral band of the entry sample of data collected in the study is statistically unreliable. However, we have very different results in different study areas. The most reliable correlation was found in Daugelaičiai and Upytė area, in this area. The weakest correlation was found in the area that very overgrown with perennial grassland. No-till technology was applied or extremely intensive tillage and manure fertilizer were carried out. There are Pavartyčiai, Lyduokiai, and Liepalotas area. This in this area. The strongest correlation is characterized by soil moisture and humus properties in the Daugialaičiai and Upite area. The weakest correlation is characterized of bulk density, aggregate index, as well as sand particles. The soil cover of the study area, which have the best correlation with the RGB spectrum band, look like this. As we can see, the area characterized by a regular change in color gamut. However, even such an image does not guarantee a reliable correlation between the properties of studied soil cover and RGB spectrum bands. Liepalotas area is very intensively used in agriculture, and data we collected immediately after its fertilization with manure. But I cannot answer why the soil cover indication of Vievininkai area in this area had a weak correlation with the RGB spectrum band. As we can see, they are characterized by a regular change in color gamut. This may have been influenced by the complex geomorphological situation of the area and different tillage methods during the study area. Conclusion. The study was conducted under real conditions. We have reflect a wide variety of not only land cover condition, but also applied agrotechnical condition. The study showed that the result obtained under controlled condition perennial test and other should be treated with caution of they may not correspond to the real condition. Regional summarize of the result of such experimental work are not possible because there are too many variables determining the topsoil properties of the soil, such as soil moisture, humus content, bulk density, and so on. The methodology used in the study can be used for mapping of local years and identify selected topsoil properties, but the results that are obtained can only be interpreted with the study area. And thank you for your attention.
The broad design for Lithuania. It was pilot idea, or are you going to develop it to the whole Lithuania?
Yes, in this time it is a pilot project, pilot results for our study. And maybe in future we can develop this study developed.
Some technological system.
Yes, we need money and collaboration with other researchers in other countries.
Have you included digital terrain model in your considerations?
What do you mean digital terrain model?
Precise changes in the height of the terrain, relief.
No, in this stage of study, we have none included.
Okay.
And here is one question in the chat. But it's I think it's not need to answer, because here is concerning grammar of the word. It's written that humus materials is written with double M letters. So it's comments. It's a grammar question. You do not need to answer to this. Okay, thank you, Jonas.
Okay, so welcome the last speaker, our session from Poland, but I couldn't read your name. Sorry, I know you a little, yes, but my pronunciation will be for sure bad. So please introduce yourself.
I don't have that screen here. Yeah. Thank you very much for having me today. I'm Guillaume Deban from Poland. I mean the French one. I'm here to give you a short presentation of a new project I'm involved in, PropField. PropField, the full name is quite long. It's a novel protocol for robust in-field monitoring of carbon stock and soil fertility based on proximal sensor on existing soil spectral libraries. So I suppose it's very nice that Piotr had the presentation just before me. Maybe I will be able to explain why some of the spectra we are looking. I'm not saying bad, but especially that I've scanned many of them, so they are so quite good. But maybe I will have some answer to give. About my name and the fact that I'm French, I like to congratulate the organizer of the conference, because I'm not anymore the more exotic participant of the conference. So it's very nice. So the PropField project is an internal project from a internal proposal from the main Earth Soil project, which is very huge. It's the biggest soil project in, I suppose, in Europe, maybe in the world. In PropField, we are focusing in many parts of Earth soils. Mainly, we will try to harmonize database, give a new protocol for scanning samples in the field. Maybe it will help a little bit Piotr. And the final aim is maybe to try to give some answer about how many carbon you can find in the soil. So it's a new project. It started in November, but effectively it's only started not long ago, because there's a lot of involve field experiment. So in winter, it wasn't possible. The budget is 2 million euros. The coordinator from the Swedish Agricultural University is Bo Stenberg, the co-leader Maria Knadel for Aarhus University, and I am the responsible for Poland and Jung. So it's a quite interesting consortium. I had to put all the names here, so this is a slide. And within the consortium, there are some of the best people in near-infrared spectroscopy. So I think if we can't find a protocol, nobody will find it. I hope. So this is a kind of small abstract. I sent it here to be put in the abstract book. It's quite short, but everything is here. The main focus of the subject is to find a quick and simple soil analysis directly in field through proximal sensing. Proximal sensing, as Piotr said, it's when you are recording. Here it's visible on infrared spectroscopy from less than 1 meter, but mostly it's almost contact. We will focus on visible and infrared spectroscopy since most of the spectral database available in the world are from this near. And the problem is that all the spectral database available in the world, I am responsible for the Polish one, which is quite huge, actually, are made of samples scanned in the laboratory condition with dry and grounded or sieved sample. But when you are in the field, there is a lot of moisture. The soil surface is not, it's quite rough. And there can be micropore, micropore, aggregates. So the light will go everywhere and that will cause some noises. Maybe I will skip a little bit here. What we want to do, we want to use the existing spectral database for calibration. When I mean calibration, it's using the spectral information with the available information we have from this database. I mean soil carbon, azote, soil texture, azote, I mean nitrogen. Sorry, to be able to predict some new samples. Unfortunately, there is large differences between this near spectrum and field spectrum. We will try to simulate as much as possible the laboratory condition in the field. And then we will adjust the spectrum mathematically to remove some field condition, for example, moisture. And if everything is okay at the end, we will add some additional sensor in the field to improve the prediction model and estimate the carbon storage. In fact, how it's going. I will not describe the work package 1 because it's the same in each project, I suppose. But mostly in work package 2, which I'm the co-leader, we will go in the field and with our instrument, spectroradiometer mostly, and we'll try to scan new samples, but we maybe find a protocol how to scan it if we had to remove a thin level of source or compact or things like that. And the optimal instrument condition needed, maybe we will mostly use contact probe. As Piotr said, when you are using some lenses from few centimeters or 1 meter, there is too much noises. And the aim then is to have a very nice spectra which looks mostly like laboratory spectra. And then in work package 3, we will use some mathematical algorithm to remove any noises. And then we will build some model of prediction for soil carbon, soil nitrogen, texture, things like that. The problem when we are trying to combine several soil spectral database
is that people are using many different instruments. Those are the one we are using at Jung in Puławy in Poland. This is one problem, so we need to find the correct protocol. The second problem is when you are measuring in the field, the samples are not sieved or grounded, and so the light, which from the light source, which can be, if it is a contact probe, it's built in. There will be a lot of diffuse reflectance in the soil with the aggregates micropores with the soil texture. And then we need maybe to prepare the soil before scanning. We don't know yet. We will try many things, but I can't tell you now here because it's I can't. But I can show you some of my other finding on the subject. When you are, there are some differences when you are using ground or ungrounded samples, like the red and the blue, is the same samples, all the red one, all the blue ones, they were grounded or not grounded, but they were sieved. And you see there are huge differences. Also, the problem when using actual existing spectral database, if you are scanning the samples, how the sample have been stored. Here you can see there are two peaks, two samples. In fact, it was sample from Jung actually, but they were stored in bad condition. And the two peak you can see here, absorption at 1,400 nanometers and 1,900 nanometers. In fact, it's a moisture absorbed from actual air, I suppose. And in Piotr spectra, he show you some huge amount of noises here. In fact, it was because in the fields are very large amount of soil moisture and contamination with the ambient light. Also, there are problems where to scan. In the laboratory, all samples are homogeneous, so you can scan several times the same samples, the spectra will be the same. But here, the red spectra on the left part of the slide is the same sample, but scanned on different places, few centimeters away in the field. And you can see there's some kind of differences. The other examples, it's also grounded, ungrounded samples and wet and different kind of the same samples, but one was almost dry and not, and the other one, it was much more wet condition in the field. So maybe we need to dry the sample in the field or to wet the sample in the field to have something homogeneous. I suppose Piotr also remember that figure. If not, it's not good because it's from our paper a few years ago. It's a PCR of spectra, in fact, spectra information, and you can see during the drying process, the spectra are moving along the principal component axis. So it means if you want to scan new samples on the field and do prediction using actual spectral database, depending on the temperature, if it is wet or not, if it's sunny or not, hot or not, the spectra will be different. So that's why we need a protocol how to take new samples, to scan new samples in the field in kind of homogeneous ways. I have presented several times that slide, maybe one time here even, maybe in Krakow. Because Piotr haven't explained you how to build a prediction model, but here I just wanted to show you that when you have an actual existing soil spectral database, it is a Polish one with 2,000 or maybe more samples. You can take, we want to take new samples in the field. In fact, actually, each point is a spectra, but it's not important. For example, we are taking samples here, and you want to predict the carbon content, for example. So we will use some kind of complicated algorithm and build a calibration model and predict new, for example, the SOC, and build new digital maps. But the problem, if you can do that. You can do that if you take the sample actually in the field, go in the lab, dry, sieve, and scan, and then probably you will have a nice, like here, regression. But if you want to be quick and don't use much money, you go in the field, you scan, you do that, and the model is not so nice, isn't it? So we want to avoid that and go in the field, scan, then do some small mathematical pretreatment and obtain a nice regression for prediction of such properties. So for the Polish part, I'm sorry it is in Polish, yeah, it's normal for French, but I already wanted to say that we have the huge Polish spectral database in UM with some different kind of regions from whole Poland, in fact. And what I'm doing, I'm taking that spectral database, and I will, within the project, I selected few experimental stations in Poland near Puławy because I don't want to move too much. And I will select new sample, scan on the field, use the protocol we are working on, and try to predict those new samples without any new laboratory analysis. And it is the main part of the project. It's not very important how the explication here, but I only wanted to show you because we don't have any result yet. Only we are preparing a few papers, but these are review papers, not very interesting. And finally, I mean, what we want to do is to send only one guy on the field. He will scan a few samples, and then he will go back in the lab with the spectra, and within a few minutes, maybe we will have the content of carbon, soil texture, everything which is available in the actual soil spectral database. It was very short, but it's only to present the new project I'm involved with. So that's all, in fact. But if you have any question, or if you have some samples, because I don't know of any spectral database in Lithuania, Lithuania, or anything else, I am very willing to take your sample, scan here or somewhere else, and build a spectral database for your countries, and maybe incorporate in the Polish one. So I'm very willing to have new sample from Baltic or somewhere else. So that's all. Thank you.
Interesting presentation. Please, questions to speaker. Any questions? It's not so easy subject to give any questions to you. Because if I good understood your presentation, to interpret the results, there are a lot of problems. Problems with this, problem with this, problem with this.
Yes. I mean, when you are in laboratory condition, everything is very nice, and the method now it's working since several years. But when it's not very practical. I mean, it's very quick. You don't have wet chemistry, but we want to go on the field, scan the sample, which is 20 seconds, 30 seconds, and incorporate the new spectrum in the actual existing database, and obtain the prediction of soil properties within minutes.
But also Jonas and Piotr say that is still a lot of problem. The correlation between the data are not very good.
The difference, but with Piotr, all the spectra, because I was also involved in the actual scanning of the sample, it's only from one field, and all calibration is done on the wet samples. We don't have information for actual existing database which are working very well. So it's something a little bit different. But if we go back with the new protocol, add a few pounds of Piotr, because it's agreed with 36 samples of, I don't remember how many. Maybe then, if you use a new protocol,
maybe it's better to use a contact probe. Piotr has one, I have one too. And scan the sample in the good condition, then the prediction will be much, it's the aim of the, we know that in the field, if you are doing everything in the field, it's bad. You can find some paper which are very good, but I don't believe much in that. I mean, we weren't able to obtain some nice results.
Okay, I check a chat. There's no questions, so I think thank you very much.
Thank you.
All speakers today, and we shall close this session.
So, dear colleagues, we are approaching the end of our meeting, sitting, discussing, listening, but it's not the end, of course, because we hope we will continue. And here we have Professor Andrzej Bieganowski, and I would say he was the pioneer of this idea, and now he is a strong promoter, and he always think where and how to do next meeting. Of course, for those who will organize next meeting, maybe there will be some natural problems, but everything is possible to solve in the best way, in the best time. So now I would invite Andrzej for some words to summarize what we did today, what we heard today. And after that, I again will take this microphone for 1 or 2 pleasant moments to announce. So please, Andrzej, tell us your opinion.
Thank you very much. First of all, I would like to thank all participants here in this hall and in the internet. We heard a lot of lectures. The lectures were the methodological, the developing of the methodology, the improvement of methodology. The lectures were about the results from the micrometers to the field scale, even in the country scale. So I think it was very fruitful. We had a lot of discussion, not only during the lectures, but during the coffee break. I saw that it was a lot of discussions, and I believe that we'll prolong these discussions during the lunch. But I would like to say something to make an impulse for the future. But before, I would like to thank you very much for the organizers. It was very professional and very good prepared symposium. And thank you also for your warm hospitality for us. And now about this impulse for the future. Piotr, during his speech, told that the science is the identification of the problems and trying to solve them. From my experiences, that very often we do half science. We know about the problems, but it's not so easy to solve them. That is why I hope that we'll have the impulse to the work, to present our results in the next symposium, and we have the invitation to the Czech Republic. You will be informed by the email. I hope that it will be in the same maybe time as now. I hope also that COVID will not destroy our plans. So I thank you for this meeting, and please accept my wishes. All the best in your countries, in your scientific activity. And I wish also all the best to the Ukrainian who fight now and are not able to do their science. I mean the scientific activity, but of course all citizens now have the problems. I would like to remember about them also. Thank you very much.
So what do you think about pleasure? What might it be for scientists? It would be some kind of recognition. So our board of our Soil Science Society, in recognition of your excellence in soil science and your contribution to our relations, decided to grant a honorary membership for Professor Dr. Habilitatus Andrzej Bieganowski. Also, in addition, golden mark. I don't know how much it is gold. What is concentration of gold, but it's golden. And we didn't stop with one honor membership. We decided to honor also Professor Habilitatus Dr. Engineer Tomasz Zaleski from Krakow. You. So, would you like to tell some words? Are you happy?
I'm shocked. Happy, of course, but I didn't expect so honored awards. It's okay. So thank you very much for your society for this honor for me. So this is because a good relationship between people. So as I remember, I met first time the Rimantas in 2003 in Polish Congress of Soil Society in Krakow. When we meet, we was much younger. As Rimanta said, less podzolization here. And we, for the first meeting, we speak very well, and we feel some good relationship between people, me as Rimantas and Tomasz, and also we come from different countries. So maybe it's the reason that our relationship still is growing and is keeping good condition. Continue. So thank you very much. I'm really impressed. Oh my God. Thank you.
Thank you very much.
So, applaudissements for new nominants. And very final remark, we have to close our meeting and to switch out our online also presentation. So thanks for everyone, everybody, ladies and gentlemen, friends and colleagues. Thank you very much that you are here for this meeting. Thank you.